Hello, you're welcome to my YouTube channel. In this video, I'm going to be solving this interesting exponential equation. So what we have here is 4 into bracket 9 raised to power x plus 3 into bracket 4 raised to power x close bracket is equal to 13 into bracket 6 raised to power x. Wow, this is quite interesting. So what do we do first? Let me divide through by 6 raised to the power of x. Now the reason for that is because I want to get rid of 6 raised by x from here. So I will just have 13 on the right hand side. Are you ready for this? Let's do that. So divide through by 6 raised to the power of x. So I'm going to have this. I can divide it by 6 raised to the power of x. All right. Then plus same thing here. 3 bracket 4 raised to the power of x divided by 6 raised to the power of x is equal to 13 bracket 6 raised to the power of x all divided by 6 raised to the power of x. Now watch this. This cancels this, so I just have 13 on the right hand side. Now what about this? Let me group this one here like this. I'm going to have 9 raised to the power of x over 6 raised to the power of x. Of course, you can do that because if you multiply this, you get this back. All right. What about the second term? Yeah, sure, we'll do the same thing. So 3 bracket 4 raised to the power of x over 6 raised to the power of x close bracket is equal to what now? 13. Now, from one of the laws of indices, if you have a raised to power m over b raised to power m, you can, since they have a common exponent of m and m, you can write it like this: a over b, all in a bracket, a raised to the power of m. This and this are the same. So that's what I'm going to do to this term here and this term. Are you ready? Let's do it together. So I'm going to have what? 4 bracket 9 over 6 close bracket raised to the power of what? X. Good. Then plus 3 bracket 4 over 6. I'll do the same thing here. Raised to the power of what? X. And this is equal to 13. I can simplify what I have in the bracket, as you can see. So here, 2 here, no, not 2. 3 here is 3. 3 here is what? 2. What about this? 2 here is 2. 2 here is what? 3. Okay, good. So I now have what? 4 bracket 3 over 2 raised to the power of x plus 3 bracket 2 over 3 raised to the power of x is equal to 13. Now, I want you to look at something closely. Look at this. This is 3 over 2, right? Or this is 2 over 3. I want to simplify this equation. Yes, I want to simplify it. Now, for me to be able to simplify it, I can just say let y be equal to this. All right? I can do that. But the challenge we have is that this is 2 over 3 and not 3 over 2 as we have in this first term. I will now use the negative index rule in indices to get 2 over 3 to become 3 over 2. Now here's what I mean. Let me show you something. In indices, if you have a over b, all right, and you want to inverse this fraction, you can write it like this: b over a, put a bracket, then raise the power of negative 1. This negative sign you see here is the reciprocal. If you want to get rid of that negative sign, you have to take the reciprocal of what? B over a. And if you take the reciprocal of b over a, it's same thing as turning the fraction upside down. All right. So if you turn b over a upside down, what are you going to get? A over b. So that negative sign is responsible for taking the reciprocal. If you must take the reciprocal of a fraction, you must put a negative sign that will counter that reciprocal you have implemented in the fraction. So the reason why I'm trying to take the reciprocal is because I want 2 over 3 to become what? 3 over 2. And then I can now assign the whole of 3 over 2 raised to the power of x to be equal to another variable. All right. So let's quickly do that together. So I'm going to have what now? I'm going to have this written. So let's just put this in a box. This is something you must know. Then I have 4 bracket 3 over 2 raised to the power of x plus 3. Now watch this now. If I write 2 over 3 as 3 over 2, so I'll put a minus, then x. Notice this was just x, but now I'm having what? Negative x, because this negative sign when applied to this fraction, we return it to what? 2 over 3. So nothing has changed. I just made it to look like this right here, okay? So this is equal to what? 13. Are you with me? Now, I will do something else. Watch this. I'm going to say 4 bracket 3 over 2 raised to the power x plus 3. This minus sign can become 1 over 3 over 2 raised to the power of x. There's no negative sign here again. See, this negative sign is what you have here. Let me show you. Is what you have here. Okay? Everything is still from the law of indices. If you have a raised to the power negative 1 and you want to rewrite this, you can write it like this: 1 over a. So this is a negative index law. So that's what I just did then. I removed the negative sign from the exponent, but I decided to take the reciprocal of 3 over 2 all raised to the power of x. Hence, I have 1 over 3 over 2 all raised to the power of x. Hope that makes sense now. So this is equal to what now? 13. Now, I can now say let 3 over 2 raised to the power of x be equal to, we can say y. I will now end up having a very simplified equation. So I will have 4. Remember, this is now what? Y. See that? Then plus 3. 1 over, as you can see here, 1 over what now? Y. You see? This is equal to 13. So if I rewrite this, I will have 4y plus 3 over y is equal to 13. Now, I don't want a fraction. What do I do to get rid of the y in the denominator? I will multiply every single term by y. So I have 4y times y plus 3 over y times y is equal to 13 times y. Now y cancels y. 4y times y is 4y squared plus, what do you have left now? 3. Then when you move 13y to the left hand side, you have minus 13y. All is equal to what? 0. So I'm going to rewrite this as what? 4y squared minus 13y plus 3 is equal to 0. Can you see now that we have a quadratic equation, which will be easy to solve? Okay. So if you want to solve this, this is how you do it. I don't want to use the formula method. I don't want to use completing the square. What am I going to use? I'll just use normal factorization method. So I will multiply 4y squared by 3. If you do that, what are you going to get? 12y squared. So you think of two factors. When you multiply these two factors, you will get 12 because this is the coefficient of y squared. But when you add these two factors, you will get negative 13, which we have here. What are they? Now, the two numbers must be negative because of this negative 13. All right? And when you multiply two negative signs, it gives you what? A positive number. Hence, this 12 will just be okay for that. So what are the two factors? I think negative 12 and negative 1. What's negative 12 times negative 1? That's what? 12. But negative 12 plus negative 1 will give you what? Negative 13. Now, there's a shortcut I can implement here. In case you don't know about it, let me show you. Because this one is 4, usually you will not open two brackets and just put in the two factors. If you put y here, you put y here. I'm not supposed to do this because this coefficient is not 1. But I'll show you how to bypass that. And let me show you what you can do. So the two factors we talked about are what? Negative 12 and what? Negative 1. Now, because we have 4 here as the coefficient of y squared, I am going to now divide the constant term, this by 4 and this by 4. That's all. So I can say that y minus 12 over 4, what's 12 over 4, by the way, is what? 3 in bracket, and then what? Y minus 1 over 4. So y minus 1 over 4. So using zero product rule, it therefore means that y minus 3 is equal to 0, or this other one here, y minus 1 over 4 is equal to 0. So here y is equal to 3. If you move negative 3 to the right hand side, you have positive 3, or y is equal to what? When you move negative 1 over 4 to the right hand side, you get 1 over 4. So we have gotten the values of y. Now remember, we're not trying to get the value of y. It's x. So recall that what? Recall that y is equal to, let's go check what y is. See it here, 3 over 2 all raised to the power of x. So we now want to get the value of x. Now, first of all, I'll say when y is equal to 3, so all right, 3 is equal to, I'm now substituting, all right, so 3 is equal to what? 3 over 2 raised to the power of x. But I'm going to take the logarithm to both sides so that I'll get the value of x. So I have log 3 is equal to log 3 over 2 raised to the power of x. From one of the laws of logarithm, this will become what? If you have log a raised to the power of n, this can be written as what? N log a. Notice the exponent of a is now multiplying the logarithm. So that's what I'll do here. So log 3 is equal to what? X log 3 over 2. So let's divide both sides by what? Log 3 over 2. So here log 3 over 2 and here 2 log 3 over 2. So this cancels this and we can say that therefore x is equal to this, which is what? Log 3 over log 3 over 2. But I want to make all of this neater. I just want to compress it and have one logarithm, a single logarithm. I'm going to use change of base. How does it work? If you have log a over log b and you want to change the base, the common base here is what? 10. But if I want to change the base, I can write it like this: log a base this other argument b. This is how you do change of base. And that's exactly what I'll do here. So I'm going to write that x is equal to what? Log 3. Then base what? This 3 over 2. So this is one of the values of x. Let's go get the other value of x. Remember that the other value of y is what? 1 over 4. So I'm going to say when y is equal to 1 over 4, when y is equal to 1 over 4, remember that what? Y is equal to 3 over 2 all raised to the power of what? X. Now replace y for 1 over 4. So I have 1 over 4 is equal to 3 over 2 all raised to the power of x. What do I do next? As usual, I'll take the logarithm of both sides. So log 1 over 4 is equal to log what? 3 over 2 all raised to the power of x. Still using that same law of logarithm, this x multiplies the logarithm. So I'm going to have what? Log 1 over 4 is equal to x log 3 over 2. Again, when you divide both sides by log 3 over 2, you do the same thing here. So this cancels this, and then x is equal to what? Log 1 over 4. Now, still using that change of base I told you about, I want to make this become a single logarithm. So this will become the new base. So I'll just put it here, 3 over 2. Now this is the other value of x. Let me bring them together. So x is equal to this, or x is equal to what? Log 3 base 3 over 2. Now we have the values of x. Now, in order not to make this video too long, I'm going to only test back into the original equation by using this one. You can try this other value of x by yourself and tell me what you have in the comment section. So I'm only going to plug in the value of x, this one here, back into the original equation, and let's see whether it will give us what we have on the right hand side. But I will only be using this one here. See, now this is the original equation, right? But I'll be using this one so that it will be easy for us to just get our answer. I'll be using this one. If I plug in x into the left hand side, I should be able to get 13 on the right hand side. So once that is done, then I can conclude by saying that yes, it is true that the value of x is what we had before. Let's go back and plug in x into the original equation. So let's plug in x into this. That will be 4 bracket 3 over 2. What is x? X is what? Log 3 base 3 over 2. Then plus 3, 2 over 3. What's x? Same thing, log what? 3 base 3 over 2. Let's see if this will give us 13 on the right hand side. Now there's a law of logarithm. If we have the base of the logarithm like this is the base of the logarithm, and this number here, since they are the same, 3 over 2 here, 3 over 2, we can cancel out like this. All right, so that's gone. I just have 4 then times 3. So 4 times 3. Plus, what about this one here? So for this one, this is what? 3 over 2. But this is 2 over 3. Remember what I told you about this before? I can decide to flip this again to 3 over 2 so that it will match with this base here. This is 3 over 2, but this is 2 over 3. So if I flip it, I will have to bring in that negative sign that is responsible for taking the reciprocal of numbers. So I'm going to have 3, then bracket what? 3 over 2. Notice I am taking the reciprocal of 2 over 3. But you have to introduce a negative sign to the exponent. So that would be log 3 base 3 over 2. From one of the laws of logarithm, the one we did before, if you have log a raised to power b, this is what? B log a. And you can take this b back to a. So that's what we're going to do with this negative sign here. We'll take it back to what? 1. So I'm going to have what now? 4 times 3 is what? 12. So that's 12 plus 3 bracket 3 over 2. Then log 3 raised to the power of what? Negative 1. Where's it coming from? Here. Here. So base what? 3 over 2. Now, like we said before, this base of the logarithm and this general base are what? The same. So I'm going to cancel out like this. And then I have what? 12 plus 3 times, what's this? 3 raised to the power of what? Negative 1. So this will be what? 12 plus 3 times, what's 3 raised to the power of negative 1? Like I explained before, is what? 1 over 3. And you can cancel out like this. So you have what? 12 plus what you have here is now what? 1, which is what? 13. So can you see that it gave us 13 as we had on the right hand side? So like I said before, try to use the other value of x, test it back into the equation, and let's see whether you get 13 on the right hand side. Do let me know what you were able to get in the comment section. I hope you have subscribed already to this channel. Do like and share this video. I'll see you in the next one. It's bye for now.